So let's continue with our operations on matrices, and so far we've looked at transpose, equality, addition, subtraction, and scalar multiplication of matrices. In this particular video, we will study the multiplication of two matrices. Now, understand the multiplication of two matrices isn't as straightforward as addition or subtraction. It is only defined under a particular condition. The condition is that the number of columns of the first matrix must be equal to the number of rows of the second matrix. What that means to say is, for example, if I have, let's consider an example, if I have a matrix A of the order 3 by 2, and if I have another matrix B of the order, say, 2 by 1, right? As you can see now, we've written the order of A as 3 by 2, which means 3 rows and 2 columns. The order of B is 2 by 1, which is 2 rows and 1 column. So matrix multiplication is defined only if the number of columns of the first is equal to number of rows of the second. And so in this case, as you can see, matrix A into matrix B is defined, right? We will get matrix A into B, which we can see what it is later on. Similarly, if I consider a matrix M, which is of the order, say, 4 by 2 rather, which is 4 rows and 2 columns, and if I have another matrix N, which is also of the order 4 by 2, which is 4 rows and 2 columns. As you can see here, the number of columns in the first matrix is not equal to the number of rows in the second, and so in such a situation, the matrix multiplication is not defined. All right. So this was about when matrix multiplication is defined. Now let's talk about what would be the order of the product matrix, right? That will be the same as the number of rows of the first matrix by the number of rows of the second matrix. What I mean by that is, let's consider the same example as earlier. If I have matrix A, which is of the order 3 by 2, right? So 3 rows and 2 columns. And if I have matrix B, which is 2 rows and 1 column, so it's a 2 by 1 matrix, right? First of all, again, the matrix multiplication will be defined since the number of columns of the first is equal to the number of rows of the second. And when I multiply the two, where did this white color come from? And now when I multiply the two, the resultant matrix that I have, right? So suppose I end up with a matrix C, will have the order of the matrix C, the resultant matrix C, will have the same number of rows as the first matrix, right? And the columns as the second matrix. So the order of matrix C will be 3 by 1, right? The number of rows of the first matrix, which is 3, and the number of columns of the second matrix, which is 1, if you notice here, right? So if I had to summarize this entire thing, right? In order to summarize this entire topic that we just looked at right now, suppose if I have, let's just summarize this. Suppose if I take a matrix A, right, and of the order M by N, right, and if I'm multiplying it by a matrix B, right, first of all, realize the number of columns in the first must be equal to the number of rows in the second, so the number of rows in matrix B has to be N. And suppose it has suppose it has P columns, right? After multiplication, suppose I get the resultant matrix as C. The order of matrix C will be number of rows of the first, which is M, by the number of columns of the second, which is P, right? And so there's a little pattern which emerges here, or a little design which could help us remember this. You can see the number of columns of the first is equal to the number of rows of the second. Only then is matrix multiplication even possible to begin with, right? The number of rows of the first is equal to the number of rows. That's a very crooked line. The number of, let's redraw that. The number of columns, the number of rows in the first is equal to the number of rows in the resultant matrix, right? And the number of columns in the second is equal to the number of columns in the resultant matrix, right? And this little pattern over here is something that we will probably be revisiting again and again in our sums, so it'll be good to kind of remember it, right? So let's just mark this as important. Yeah. In the next video, we will take an example and actually see how to multiply two matrices, right?